right? So here we have the numerical, right? So we'll see how to draw the table. Okay, so if we go through the question, a shaft carries 4 masses A, B, C, and D, right? A, B, C, and D. So these cross lines are these masses of magnitude 200, 300, 400, and 200 respectively. 200, 300, 400, and 200 respectively, right? And revolving at radius of 80, 70, 60, and 80 millimeter, right? So radius 80, 70, 60, and 80 respectively in planes measured from A at 300, 400, 700, right? So from A, the distances for B is 300, for C is 400, and for D is 700, right? From A at 300 meter B is there, at 400 meter C is there, and 700 meter D is there. All right. So now you are given with the masses, the radius, and the length between the planes, right? And now the angles between the cranks measured anti-clockwise are A to B 45, B to C 70, and C to D 120, right? A to B 45, B to C 70, C to D 120 in anti-clockwise direction. So that is this direction, right? You know, anti-clockwise means this direction. These angles are given. So while in the exam paper there can be twist, right? So it can either be A to B 45, B to C 70, and C to D 120, right? So here it is clear. A to B 45, B to C 70, C to D 120. There can be incidents, right? From A, the angles for B, C, and D are 45, 115, and 235 respectively. So this sentence can be expressed in other way. From A, the angles for the plane B, C, and D are 45, 45 plus 70, 115, and 115 plus 125, 235 respectively, right? In that case, this is 45, this is 115, and this is 235. So you need to read the question carefully, right? So this data can be expressed in either ways, right? The balancing masses are to be placed in planes X and Y. So it is given where we want to place the balancing masses. The distance between the planes A and X is 100 millimeter. So distance between A and X is 100 millimeter. So now they have given where we need to place the plane X, right? Where we need to place the X plane, and Y is 400 millimeters. So now Y is also given where we have to place, and between Y and D is 200 millimeters. So once you have drawn, you can check that one, right? So from A to X is 100 millimeters, right? So here we have the A to X is 100 millimeter, okay. X and Y is 400 millimeter, right? From X and Y, this is 400 millimeter. Then between Y and D is 200 millimeter. From Y and D, this is 200 millimeter, right? So this is clear. If the balancing masses revolve at a radius of 100 millimeters, so now the radius of the rotation of balancing mass is given. Find their magnitude and angular position, right? So now we need to find the mass of the balancing mass as well as the angular position where we need to place them. All right. So these are the given data. MA, that is masses are given, radiuses are given, and distance between planes are given, right? Okay, then we will place them in the table, right? So planes we know in the order, that is AX, B, C, Y, D, right? So we need to write it in the order AX, B, C, Y, D. And we have taken X as the reference plane. You can take any one of these plane as the reference plane, right? But usually what we do, we will take either X or Y as the reference plane, because there are more unknowns related to this X and Y, because all the A, B, C, and D all are knowns, right? With X and Y, the unknowns are high, right? Then the mass. So we know A is 200, B is 300, C is 400, and D is 200, but this x and y we don't know. We will put mx and my respectively. Okay. And about the radius, so radiuses are given. So we know all the radiuses, right? So A 0.08, B 0.07, C 0.06, and D 0.08. And in the last sentence, it is given the radius masses are expected to rotate at 0.1 meter, that is per 100 millimeter, right? So we will write it like this. So you can either write it as radius in meter, or if you wish, you can write it in a millimeter also. But whatever you are doing, keep the units throughout the numerical identical, right? Don't change between the units, then you may end up in like, you know, mixing up meter and millimeter, and you will end up in a kind of decimal problem, right? Then once you are done with the radius, right, now we have mass, we have radius, so centrifugal force we can find. So force actually it is mr omega squared, but we are not going to consider omega squared here since it is same for all, right? Then we will go with m and r, right? So we will multiply this and put it in the table, right? This is centrifugal force. So you multiply these things. So 200 into 0.08, 16, mx into 0.1, mx, mass into radius, that is 300 into 0.07, 21, 400 into 0.06, 24. This is 0.1 my and 16, right? 200 into 0.8, 16. So now you got the force, right? Forces acting on each plane, right? Now we will put the distance from the planes, right? So here x is taken as reference plane, so I put x as 0. If you have taken A as reference plane, you can put here 0, or Y as reference plane, you can put here 0. That's up to you, right? Usually what we do, we will take either x or y as the reference plane, right? So from reference plane, one side would be negative and one side would be positive. Either you can have that as positive and this as negative, or this as negative and this as positive. That's up to you. All right. So here that is 0, distance between these two planes. So these data are given, right, in the numerical. So 0.1, 0.2, 0.3, 0.4, and 0.6, right? So in this diagram, if you see, right, 0.1, right, x2 A, that is 100 millimeters, 0, it is 0.1. Here x is a reference plane, that is 0. So x2b, that is, so if it is 300, and if I reduce 100 from that, this is 200, right? So that is 200, that is 0.2 meter. Then x2c, right? x2c, this is 400 minus 100, that is 300, right? That is 300. Then x2y, right? x2y, this is total 500 minus 100, that is 400, that is 400. Then d, right, from x, 700 minus 100, that is 600, right? So these are the distances between planes measured from the reference plane, right? Measured from the reference plane, right? So now we are done with the planes, distance between planes. Now we will calculate the couple, right? Couple, you know, m into r into omega squared into L. Since we don't consider omega squared here, that will mr into this distance L, right? So mr we have already multiplied here into this distance, we will place here, right? 16 into 0.1, that is minus 1.6, because this is taken as negative, right? So if this is taken as negative, then all the other are taken will be as positive, all right? So here 0 into this mass, that is 0, 0.2 into 21, 4.2, 0.3 into 24, 7.2, 0.4 into 0.1 my, that is 0.4 my, sorry, so 0.04 my, 16 into 0.6, that is 9.6, right? So this is the table we have prepared. Now, with the help of this table, we will be drawing two polygons. One will be called as couple polygon for this couple, and one will be called as force polygon for this force, okay? So for these data also, we will draw a polygon. For these data also, we will draw a polygon, all right? So let us start. So here we have the space diagram. So these will give you the angles. Based on this, you will draw the magnitude according to this, right? So I will start from any point O, right? Yes, any point O. We can draw couple polygon and the force polygon. Okay, these two polygons we need to draw in order to find the masses, because two unknowns, two formulas we need, so we need two diagrams. So which one do you think better to draw first, whether the couple polygon or force polygon? Drawing couple polygon or force polygon first will not be a general answer, right? So based on each question, that may vary, right? So here in this numerical, we will draw couple polygon first and then go for the force polygon, because the reason said by Kaushalya is correct. From the couple polygon, we can find my because there is only one unknown quantity, right? So once I found this my from the couple polygon, I can replace that my here, all right? So now I have only one unknown here in the force polygon, right? So this is the reason I will start with the couple polygon first. In case if I start with the force polygon first, I will have two unknown mx and my, so I can't finish the diagram, right? I can't finish the diagram. So that's why we should start with couple polygon, because there is only one unknown, right? So this logical argument is common for all numerical sections, right? Wherever you have formulas and you need to solve them, right? Look for the look for the formula which has least number of unknowns, right? And start from there, right? Not only for the force polygon and couple polygon, but wherever you are solving some numericals, right? This is common general rule. You look for a formula with least number of unknowns and start solving from there. But if you started with somewhere here, you would not be able to draw the polygon. I will explain why is that. Okay, let's see with the diagram of the couple polygon. So this is our diagram of couple polygon, right? So some of your arguments were these angles and these angles were aligning exactly, right? Yeah, that's true. But at the same time, these angles will also align. We'll see. So OA, right? That is not 0, that is O, right? OA. Since this OA is in negative, right? That is negative. From O to A, I will not draw this way, but I will draw the other way. All right. So actually, OA is in this direction, so I should draw like this. But since that is minus, I will draw on the other way, that is minus 1.6, right? So this is fine. And this diagram you need to draw according to a scale, particular scale. So in the dynamics of machines as well as in theory of machines, the entire subject based on the scale and true values, right? So there you need to draw it according to the scale, right? So if 1.6, say for example, you can take this as 1.6 centimeter or something, you can take it, right? So that is 1.6, that's fine. Then I have 0, right? So I don't need that. I have AB, right? AB. So this angle is 45 with A, right? So I will draw parallel to this, right? X I didn't draw because that is 0, right? No problem, right? So 45 degree A with B. Since this is positive direction and this is going that way, I will take in the same direction, right? Since this have a minus, I draw this way, but since this does not have any minus, this will go this way. So that is 4.2. So maybe for our scale, say for example, if I take 1 cm as 1 unit of this diagram, right? So this will be 4.2 A to B, right? So this angle and these are parallel, right? Then next one, B to C, right? So this is going in this angle, that is 45 plus 70, right? So from here I will draw parallel line to this, right? So now these and these are parallel to each other, and the dimension is 7.2, right? So that is 7.2. Then I have D, right? From C I have D. So these two should parallel to each other, right? And the value is 9.6, right? The value is 9.6. So this is also fine, right? I have drawn this. Now I have one unknown that is equal to 0.04 my. So here we started. This is our last point of D. So now we have to join these two to make this polygon a closed polygon, right? Dealing with one disturbing mass and two unbalanced masses in different planes. So this polygon need to be closed polygon, right? So we will join this and this by a line that will denote 0.04 my, right? That will give you 0.04 my. So I will write 0.05 my. So since you have made it according to the scale, you can measure the distance between B and D, right? You can measure the distance between B and D. Once you have drawn it, you have that scale, right? So you can, okay, it's mentioned here. So 0.04 my, the vector DO, right? Vector DO, that is equal to 7.3 kilogram per meter square, sorry. So this one, it is coming as 7.3. So according to the scale factor, they are putting 0.04. My is equal to 7.3. So my is equal to 7.3 upon 0.04. So that will give you 182.5 kilogram. So now I have found the my. Right? Now I have found the my. So what I will do, I will replace that my here, right? So if I replace that my here, that is 182.5 kilogram into 0.1, that is 18.25, right? So now I have value for this 18.25. Okay, so based on the coupled polygon, or with the help of the coupled polygon, now I have found the distance between, sorry, not the distance, now I have found the mass of the my, right? We can move with the post polygon to find the other unknown mass, that is mx, and that's the other unknown mass. So with this value 18.75, right, now we have see the force polygon, we have only one unknown, right? 16 known, 21 known, 24 known, 18.25 known, 16 known. So only 0.1 mx is the unknown value, right? This is the only unknown value. So based on this, now we can draw the force polygon, right? We will go for the force polygon now. That is OA. So we will start again from the OA. So here we don't have any negatives, right? So we can go along as it is, right? So here you see OA, right? OA, that is 16. So we can take maybe for certain scale can be 1.6, right? That is 16. Then from A to B, that is 45 degree. So we will draw parallel to this. You see this one, and this one are parallel. Okay, so that is 21. You see here, that is 21. All right, so now B is drawn. Then C, that is 24. So B to C, which is in this direction, right? So I will draw parallel to this B to C, that is 24. All right, then I have Y, that is 18.25, right? We will wait for that. Before that, I have another 16, right? I have a 16, that is from C to D, right? So this is a plane which we are going to unbalance. Sorry, not unbalance, balance, right? So we will go A, B, C, D, then we will come for this, right? So O, A, B, C, D, then we will come for this unbalance, right? So C to D, you see here, C to D, this direction, right? This direction, that is 16, right? This value is 16. All right, this is 16. Then we have found 0.1 my, right? So that 0.1 my is here in this direction. You see this direction, right? This direction. So now we are done with a kind of polygon, right? So now we have only one unknown thing left, that is 0.1 mx, right? 0.1 mx. So what you have to do is join the start and final point. So here is our starting point O, here is our final point E, right? So we will join these two, right? So this dotted line shows the 0.1 mx, right? 0.1 mx. You can measure this one by, right? You can measure. So that is 0.1 mx is equal to 35.5. So according to that scale, it is coming 35.5 kilogram per meter. So mx can be 355 kilogram, right? So mx can be 355 kilogram, right? So what are the things you need to consider here is, it is not necessary the scale you are taking to draw this diagram and the scale you are taking to draw this diagram, it is not necessary to be the same. Okay, doesn't matter, it can be 1:10 and this can be 1:5, no problem. But whatever the scale factor you are taking, you need to multiply or divide by that particular scale factor, right? Doesn't matter with which scale factor you are taking, right? Right, so the things you need to consider while doing this kind of equation, I mean sums, right? You draw the table first, right? And then look for a least number of unknowns, right? Least number of unknowns, whether coupled polygon or force polygon consists of least number of unknowns. So start from there, right? Start from there, and while drawing the polygon, consider about these negative signs, right? Once you have done with that, you will find an answer, right? Replace that answer in the force polygon if you started with the coupled polygon, right? And then draw the diagram for force polygon and you can get the answer. Okay.